Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be looking at how you solve for equations with more than one variable. So this is actually a topic that doesn't get the coverage it deserves usually in an algebra type class. It's probably because it isn't used in more than a couple of sections in an algebra class. Now, we did look at this before, earlier in the year, but I felt that it deserved a relook, mainly because this was a topic that students seem to have struggled out in the most. So that's what we're going to be focusing on in this particular lesson. So let's take a look at this example and we'll go over the steps of what you normally would do in this case. All right? So, first and foremost, this question says to solve for r. Now, when it tells you solving for r, basically it's telling you this is what I care about. This is my variable, which means we look at every other term here as if we don't care about them. So I don't care about the t, I don't care about the 1, yeah, sorry, that's a 1, not an L, and I don't care about the p. Okay? So let's break down the steps we normally would do, but before we do that, I just want to, on a side here, remind you, I want to take a flashback here. That's my flashback music, sorry. So recall, if I told you solve for x plus 2 is equal to 5. Well, to get the x by itself, this is the one I care about, the x, which means this plus 2 is bothering it. So what would I do? I would subtract 2 from both sides. Why am I subtracting? Because it's originally a plus. To get rid of a plus, you do the opposite, which is minus. Okay? So x should be 3. Draw a little bit of a line around here. All right. Make this into a little submarine of our memories. All right, so I think that actually turned out pretty nice. So before we go into this, let's go into the steps. Now, the steps are pretty straightforward. The first step will be actually a loaded step, is isolate the letter that I care about. Now that's a pretty loaded step. I'm going to remind you of how you go about isolating. It's the same way you would any kind of linear equation. Okay, so you'd be following these steps. You want to get rid of so first you want to get rid of fractions. Then you want to get rid of additions and subtractions. Then you want to get rid of any multiplication. That's always the order you're going to go, and it's like you're asking yourself questions each time. So the first question I ask myself is, are there any fractions here? Nope, 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 nope. So the next thing I want to ask myself is, what is not r? Well, that's not r, that's not r, that's not r. So I'm pretty fair to say I'm getting rid of a bunch of these stuff. So my second step is, are there additions and subtractions? There actually is additions, but it is inside a bracket. So I'm going to add a caveat to this rule, and that caveat is, yes, you would get rid of additions and subtractions next, unless they are in a bracket. Okay, so I can't get rid of this addition or subtraction because it's inside a bracket. So next up, multiplication. Is there multiplication? Yes, this p is multiplying. How do I know this? Because if there is a space between this and the bracket, or this and something else, they are multiplying. So how do I get rid of this multiplication? By dividing both sides by what I want to get rid of. Okay? This is going to end up giving me A over P is equal to, with the multiplication gone, the bracket goes away 2. 1 plus RT. Okay, so now we have refreshed our situation. Let's re-ask ourselves questions here. Are there any fractions? Well, there is. There's a fraction right here. But is there an R involved in this fraction? No. So I don't need to get rid of it because it has nothing to do with my R. Next, additions and subtractions. Yes, there is. This 1 is being added. How do I know it's added? Because there's nothing beside the 1, so I assume it's positive. So to get rid of it, we're going to subtract 1 from both sides, which will leave you with A over P minus 1 is equal to RT. Now, before getting rid of the last one here, I want to put these as common denominators mainly so that I can make this look nicer. So let's get these as common denominators. So remember, this is the same thing as saying 1 over 1, which means I'm going to have to multiply the top and the bottom by P, which means I'm going to have A minus P over P is equal to RT. Finally, is there any multiplication? Yes, there is. The T is multiplying. How do I know? There is nothing in between them. So I'm going to divide both sides by the T. Now, little trick, if I'm dividing both sides by the T, this basically means I'm putting this on the bottom. So my final answer should be A minus P over PT is equal to R. Is R by itself here? Yes, it is. Therefore, this is my final answer. Okay? So let's look at a couple of other examples and try to get this hammered in our minds. Okay, so let's take a look at this example here. Now, if you already know how to do it, pause the video right here and try to do it yourselves. Okay, still with me? All right, great. So let's go into our first step. Obviously, we want to isolate the variable I care about. I only care about R, which means I only care about you. You're not R, you're not R, you're not R, you're not R, so I'm getting rid of all this stuff. So once again, is there any fractions? There is fractions, but they are inside my bracket, so I can't get to them. Same thing with the additions and subtractions. So the first thing you want to do is get rid of the M. So I'm going to divide both sides by M. Once again, you're not touching anything inside the bracket, you're just touching that M outside. So that's going to leave me with V over M is equal to, the multiplication's gone, so now you're going to be left with 1 over B minus 5AR over M. Okay? Now at this point you could do two different things. Now, you're going to have to get rid of the fractions to get to that R. So you can either multiply everything twice or get the common denominator and multiply them once. So I'm going to show you them both ways. So first way, common denominator. Apparently can't spell denominator today. Jeez. All right, so to do that, obviously, you're going to look at here, you're going to look at here. This one's B, this one's M, so what are they missing? This one's missing an M. And this one's missing a B. Which is going to turn this into V over M is equal to M minus 5ABR over MB. Okay. Next up, multiply both sides by MB. Okay. That's going to get rid of this MB. And this is actually going to get rid of this M, which is going to leave me with BB is equal to M minus 5ABR. All right. Now, is there any more fractions? Nope. Addition, subtractions? Yep. So get rid of the M. How do I do that? Subtract the M. Now, addition, subtractions, fractions, nope, nope. So, multiplications. Now, you can do this piecewise, and you could just divide both sides by b, both sides by a, both sides by -5, or you can just divide both sides by the whole shebang of -5ab. Which will end up canceling the -5ab. Now notice here, it will not cancel this b here. To cancel this b, you'd have to have a b here as well. You have to be able to divide both terms. So keep that in mind. Alright, so that's going to leave us with bv minus m. I don't like having the negative on the bottom, so let's change the signs on the top. So you have a negative plus, okay, is equal to r. R is by itself, so that's my final answer. The second way you would have had to have done it would be to multiply both sides by each denominator separately. Okay, now this is the longer way here. If you could understand the common denominator way, that's actually much quicker, but let's do it this way as well. So basically what I would do is I would have instead here, so let's write this out again. I would have had to have multiplied everything piecewise. So I would have had to have multiplied this by b to get rid of the b, this by b, and this by b. Remember, when you multiply, you have to multiply every term. So that would end up giving me bv over m is equal to, these b's cancel out, leaving me with 1 minus 5a br over m. Then I'd have to multiply everything by m. That would cancel out these m's, leaving me with bv is equal to m minus 5abr. What do we notice now? Well, we're now at the same place we were over here, so our answer is going to continue towards the same thing. Okay, so let's put up 2 more examples for you guys to try out yourselves. Okay, so let's try out these 2 questions. I want you to pause at this point and try these out yourselves before checking on the answer. Okay, I'm assuming you guys paused it. Now you've unpaused it. If you haven't been, then, well, this is probably pretty hilarious to you. Alright, so I care about C here. So I want to get rid of anything that's not C. The problem is C is on the bottom. So because of that, it falls into that first rule of getting rid of fractions. So the first thing I would do here is I'm actually going to do the common denominator way we did on the first page. So I'm going to multiply everything here because we have 3 fractions. We have A, B, and C. So I'm actually going to multiply everything by what's missing. So that would mean this A is missing B and C, BC. This one's missing AB, and this one's missing AB. And again, whatever I do to the bottom, I do to the top. So AC, AB. So what do we have? We have BC over ABC is equal to AC over ABC plus AB over ABC. Okay, so once again, first rule, get rid of fractions. How do we get rid of fraction? Multiply everything by the bottom. Remember, everything. Pokemon Go this. Catch them all. Okay. That's going to end up giving me these things canceling out. Okay. Now I want to get my C's on the same side. In this case, we have AC on both sides here. So I'm going to move this to the other side. It's already positive, which means it'll turn negative here. I don't care about the AB because there's no C there. Now, there is a callback here to when we were factoring earlier in the year. This one has a C. This one has a C, which means I can divide them both by C. And if I do that, I'd be left with, so if I divided them both by C, I'd be left with a B there, I'd be left with an A here. And now there's a multiplication, get rid of it. And that would be your final answer there. Lastly, for this one here, this one's a little bit more involved. Again, you want to get rid of fractions first. So you're going to end up having here y times this bottom here. Okay? So let's do that. I'm actually going to multiply it out at the same time. So y times 1 is y plus 8xy is equal to 4 minus 3x. Again, I want to get all my x's to the same side, everything that's not x to the other side. So I'm going to move this y over here. I'm going to move this negative 3x over here. I'm going to show you with some arrows too. So I'm going to put this negative 3x to this side, and I'm going to put this y to the other side. So originally this negative 3x was, as I said, negative. So over here it will be positive. And over here, y was positive, so over here, it shall be negative. Okay, same trick we learned in the last question. These both have an x, so I can divide them both by x. Now if I divided them both by x, I'd be left over with 8y here, 3 there. Divide both sides, leaving me with 4 minus y over 8y plus 3. Okay? And that is how you solve for multiple variables. Okay? Please follow the steps, and please let me know if you have any questions on this, and I am more than happy to help you with this. I hope this has helped everybody, and have a great day.